Have you ever stared at a blueprint and it just looked like a total jumble of lines? It can feel like you're trying to crack some kind of secret code. Well, what if I told you it's not a code, it's actually a beautiful, totally logical language? Today, we're going to learn the grammar of that language, the one architects use to literally build the world around us.
And this right here, this is the fundamental puzzle that every single architect has to solve. How do you take a massive, three-dimensional building, something you can actually walk through, and capture every last detail on a flat, two-dimensional piece of paper?
So how do they do it? Well, it's not just one magic trick. It's this amazing collection of brilliant techniques developed over centuries, all designed to solve this one epic challenge, squeezing 3D into 2D.
Okay, so the core concept behind all of this is called a projection system. The easiest way to think about it is like a movie projector. Architects are basically projecting an image of their 3D object onto a flat screen, what they call the picture plane. And that projection, that's your drawing.
Now, this language has two main dialects. The first one is the technical one, the no-nonsense view that's used for construction and engineering. And it's all built on one simple, really powerful idea: drawing with parallel lines.
So here's the golden rule for this whole system. Every single imaginary line, or projector, that travels from the object to the paper is perfectly parallel. They never get closer, they never get further apart, they never converge. Now, this might not be how our eyes see the world, but it is the absolute key to creating precise, measurable drawings, where every single millimeter counts.
Within this big parallel family, architects have three essential tools in their kit. Let's break them down: orthographic, axonometric, and oblique. First up is orthographic projection. And you gotta love the X-ray view analogy for this one. It basically means you're looking at an object straight on, perfectly head-on, perpendicular. This method preserves the true shape and scale, just like a medical X-ray of a building's face.
And this gives us that classic set of blueprint drawings you've probably seen. A plan is the view from the top down, like you're a bird. An elevation is looking at it from the front or the side. And a section, this one's my favorite, it's like you've taken a giant knife and sliced the building right in half to see all the juicy details inside. Together, they give the builders a complete, totally measurable picture.
Next, we've got axonomic projection. And if you have ever built IKEA furniture, you will instantly recognize this. It's that brilliant 3D style drawing that shows you the top, the front, and the side of an object all at once, so you can finally see how all those little pieces are supposed to fit together. Now, the undisputed champion, the king of axonometric drawing, is the isometric view. And the name itself gives it away. Iso means equal, and metric means measure. So it's an equal measured drawing, where the scale is perfectly consistent along all three of the axes you can see.
And this number, this is the secret key to spotting an isometric drawing out in the wild. The horizontal axes are always drawn at a 30-degree angle from the baseline. 30 degrees, you gotta lock that in. So, next time you see one of those exploded diagrams of a complex engine, and it has that distinct 3D look, you'll know the secret. What's the angle of those axes? You got it, 30 degrees. It is the foundational rule. All right, the last member of our parallel family is the oblique projection. Think of this one as the quick and dirty method for a fast 3D sketch. You just draw the front face of the object completely flat and true to scale, and then you just shoot the depth lines back at an angle, usually 45 degrees, to give it that instant 3D pop.
Now, this brings up a small but really important distinction. If you draw those depth lines going back at their full, true length, that's called cavalier projection. The problem? It often looks kind of stretched out and distorted. So to fix this, architects use what's called cabinet projection, where they simply cut that depth measurement in half. It's technically less accurate, sure, but it looks way more realistic to our eyes.
Okay, so we've covered the technical views, the ones used for construction. But what about showing a client what their new home is actually going to look and feel like? For that, we have to abandon the parallel lines and start drawing the way the human eye truly sees the world.
And that brings us to our second major dialect: perspective projection. In this system, lines that move away from you actually look like they're converging at a single vanishing point. This is what perfectly mimics our own vision, creating a real sense of depth where things that are far away look smaller.
You've got three main flavors here. One-point perspective is perfect for looking straight down a long hallway or a road. Two-point is the absolute classic for showing the corner of a building. And three-point, well, that's when you really want to get dramatic.
So think about this. How would you capture that stomach-lurching feeling of looking down from the top of a skyscraper?
Or that feeling of awe, looking all the way up from the street below? Which tool do you reach for?
Yep, that is a job for three-point perspective. It's that third vanishing point, placed either way up in the sky or deep below the ground, that creates that extreme convergence of lines you need for those super dramatic high-angle or low-angle views.
So, with all these different drawing types, how does an architect know which one to pick? It's not random at all. They have a kind of mental cheat sheet that helps them choose the perfect view for whatever job they're doing.
And here's basically what that cheat sheet looks like. Just look at the best use column. You'd use an isometric drawing with its fixed 30-degree angles and equal scale for, say, a technical diagram of a joint. But for a realistic rendering to show a client, you absolutely need perspective, where the scale shrinks with depth. Each system is a highly specialized tool for a very specific task.
Okay, before we finish up, I've got one last pro tip for you. It's a really simple, elegant convention that just breathes life and depth into these otherwise flat drawings. It's the secret power of shadows.
So in architectural drafting, there's this standardized practice called psiography, which is really just a fancy term for the study of shadows. The rule of thumb is super simple. You always assume the light source is coming from the top left at a 45-degree angle. This means shadows are always consistently cast to the bottom right. It's such an easy trick, but it instantly gives a flat drawing a believable sense of three-dimensional form. So there you have it, the secret language of blueprints totally decoded. From the assembly guide for your bookshelf to the design of the tallest skyscrapers, you now have the key to understanding how our 3D world is imagined and then built from a simple 2D page. The only question left is, now that you can read the blueprints of our world, what will you see differently?